We're so thrilled you're here to learn about one of Greater Yellowstone's ecosystem engineers, the amazing Beaver. My name is Emmy Reed, and I work in the Marketing and Communications Department here at the Greater Yellowstone Coalition. Before we get started, I want to run through a few housekeeping notes. Please ensure that your Zoom is on mute to minimize any outside noise during the presentation. At the end of the presentation, there will be an opportunity to ask our presenter questions. So you may submit any questions in the Zoom chat box during the presentation or after, and I will act as moderator and ask those questions out loud. Please include your name, because if we do not get to your question before the end of the webinar, we will send you a follow-up email answering your question. We're also using a feature where anything typed in the chat box is only visible to myself and my co-host, so don't worry if you don't see any questions popping up, they are coming through. Please keep all questions kind and focused on the material from the presentation. The webinar will be recorded today so that we can share it with the supporters who are unable to make it. That link will also be sent to you via email tomorrow. All right, so thank you for your patience. I'd now like to introduce our presenter, Kurt Imhoff. Kurt is GYC's Senior Climate Conservation Associate and is based out of Lander, Wyoming. He works across the Greater Yellowstone ecosystem to build climate resiliency and facilitate the adaptation of aquatic and terrestrial systems in response to climate change. A geomorphologist by training, Kurt focuses on both the technical and strategic components of watershed restoration work while building partnerships to solve the many complex issues in Greater Yellowstone related to climate change. When he's not at work, you can find Kurt exploring Greater Yellowstone's mountains, forests, and rivers with his partner Kara and dog Fisher. All right, Kurt, time to take it away.
All right, thank you, Emmy, and thank you as well for developing and moderating today's webinar and managing the Q&A at the end of this presentation. I really appreciate the help, so thanks for that. And thanks to all of you, our viewers, for taking the time to join me in this presentation today. I am happy to welcome you to this second installment of our Spring Forward webinar series, in which we'll be shining a light on beavers and their unique role in promoting climate resilience within this ecosystem. So the structure of this talk will be as follows. I want to start by shining a brief spotlight on beavers themselves, dive into their conservation history in the region, and detail out the vital role that they play within this ecosystem. I then want to discuss what happens when we lose beaver from the landscape and how supporting efforts to conserve or reintroduce these animals can help us resist the effects of climate change. At the end, I will cover some beaver-focused and specific examples that we're engaged with right now, so you can better understand what GYC and our partners are currently working on. But first, I want to give a little bit of background on myself. So as Emmy mentioned, I am GYC's Senior Climate Conservation Associate, and my primary role is to help develop and implement GYC's climate-focused conservation goals across the ecosystem. So even though I'm based in our Lander, Wyoming office at the southern end of the ecosystem, I am very fortunate to be able to work on campaigns and programs and projects everywhere from the Wind Rivers in the south to the Gallatin in the north. I get to work out of the Absaroka Front near Meeteetse, Wyoming in the east, and I get to go to that fantastic basin and range country in southeastern Idaho at the far west. And I came to GYC with a geomorphology background, having studied river processes and forms, so both how rivers shape landscapes as well as how rivers are shaped by various external forces acting upon them. And that's because I've always been curious specifically about what drives habitat states. I'm curious in why things are the way they are. And I've taken that curiosity through both the public and private sphere, working on aquatic conservation and restoration efforts all across the West. On a personal level too, and for really as long as I can remember, I have been enamored with these big, intact, wild ecosystems like Greater Yellowstone. It was the love for those kinds of places that first brought me to Montana and eventually here to Wyoming. And it's something that continues to fuel my excitement for this work all the time, constantly. And just as much as I'm fortunate to be able to work in this really special place, I'm equally fortunate or lucky to be able to live here, right? So when I'm not pursuing my climate-focused conservation goals, I'm usually out and about with my friends or my family, and almost always with my wonderful dog, Fisher Boy, who never turns down an opportunity to ride shotgun with me. And as we dive into this talk, I think the best place to start would be the beginning, right? With the stars of this webinar, which is the American beaver, or Castor canadensis. We are going to talk for a little bit about its role as an ecosystem engineer, and how these animals work to combat the impacts of climate change through what they do. And let's be real, right? No self-respecting talk about beavers can or should proceed without some obligatory fun facts. And on a more serious note, it really is because of how unique these animals are that they can have such outsized impacts on their environment. Beavers are what we call a keystone species, which means that in their absence, these landscapes start to look really different. So, while we're on the obvious train, let's start with a really obvious thing. Beavers are huge. They are the second largest rodent in the world. They are much larger than I think many of us even fully appreciate and realize. Adult beavers might be 40, 50, or 60 pounds, but they can top out over 100 pounds. So that's like 1.9 of my dog in weight. And I think that's worth thinking about, right? So for any of us who have dealt with mice or pack rats or any other smaller, 1 ounce, 3 ounce, 5 ounce rodents, you can attest to how much work they can get done, how industrious they can be, even if it's maybe not to your immediate benefit. So what does that mean for a 50 or 60 pound rodent? Well, it means that they can get a lot done, right? So beavers haul heavy loads, they topple trees, and ultimately radically change the environment that they live within. And while these impacts aren't always desirable from a human perspective, which we'll talk about later, they are important in a natural context. And beavers, like any work of art, take time to perfect. Okay, so they've been hashing out the details of their semi-aquatic lifestyle for like 24 million years, right? And that ongoing evolution is reflected in various unique physical adaptations that make them unique. So, to start, and contrary to what many people might think, their front paws are not webbed like their back paws are. They are small, dexterous little things. They can grab and manipulate small objects. They can pack mud like mortar. It's their hind feet, which are webbed, and their tails that ultimately propel them through the water. And it's in that aquatic medium that beavers are really best able to avoid predation while they're out and about. And a cool quick note on beavers too, and on beaver tails, is that besides aiding in movement and storing fat that they rely on, they actually have a circulatory system there that allows them to lose heat when they're warm or retain heat when they're cold, which is really interesting. And I bet a lot of folks here also know that their incisors grow throughout their lives, right? They're constantly growing, which is true. And what I find even more interesting is that when they're under the water, their lips actually seal behind those incisors, right? So whereas my lips are in front of my teeth, theirs are actually behind them, which means they can swim around and bite and chew and drag stuff around without letting any water into their lungs. So they are truly remarkable animals. And while beavers do burrow and create dens within riverbanks, it's really the dams and lodges they create that we're going to focus on today. And let's be honest, these are the things that are most iconic about these animals. And the ponds that they create are intentionally done and crucial, right? So beavers need these ponds to provide security as they forage or collect building materials, or even as they start to disperse to colonize new areas. Turns out it's a lot easier to haul heavy branches and sticks when you're floating them as opposed to carrying them, although I've seen beavers do the latter, so maybe sometimes they just want to get a workout in. I'll say this too, which is that beaver lodges, so these are the home structures they build and live in, they're intentionally placed so that you have to swim into them from beneath the water surface. So think of it as like a moat around a castle. So when a beaver and their partner, they form these monogamous long-term partnerships. When they get together and want to have some kits, that's K-I-T-S, they'll build one of these lodges and raise them inside. And as any empty nesters in the audience are well aware of, those kits don't stay forever. They do eventually strike out on the landscape. the key point that I want you to take at this point is that when they do this, they're not just colonizing habitat that already meets their needs, right? They're not just only looking for existing ponds and other sort of pockets of deeper water. They'll oftentimes create and sort of shape the world around them to fit their needs. When you think about, let's say, a watershed with a robust beaver population where there are many kits leaving their lodges every summer, striking out, making changes, you start to understand that beavers at larger spatial scales can really start to have an important role to play when it comes to creating and maintaining these specific habitat types. And I got to say, too, when we're talking about those large scale impacts or the benefits that beavers provide to the ecosystem, what we're really talking about is how beaver activity influences something called a riverscape. So when I say riverscape, and I will say it a lot today, I'm talking about a stream channel and its adjacent floodplains that make up a valley bottom. And by floodplain, I'm just talking about those flat bottomlands adjacent to streams, which get flooded fairly regularly, which is a natural process. Riverscapes also include something that is not pictured here, which is the subsurface. So alluvium and sediment beneath sort of the surface of the ground, but that's able to store water, right? That's where groundwater is stored. Now, we think about riverscapes when we talk about the health of river systems because it's holistic. It helps us incorporate everything interacting with each other when we're trying to understand why systems are or aren't functioning correctly. And a riverscape is inherently complicated and kind of messy, and it's reflective of a whole host of governing physical and chemical and biological processes that work together to shape that riverscape system. And it's ultimately within these riverscapes that the benefits provided by beavers are realized. So let's talk about those benefits. And maybe we'll start with one of the obvious ones, which are the hydrologic benefits provided by beaver. By slowing flow, beaver dams work to keep water within riverscapes longer. And this is valuable for a couple of reasons. Firstly, on-site water retention behind beaver dams has been shown to attenuate or lessen the impacts of flooding or repulsive flooding as it moves through a river system. Excuse me. And that could be whether we're talking about our annual spring runoff here in Greater Yellowstone, or maybe a high-intensity localized rainstorm event. The same is true in both cases. What's more, beaver ponds allow for lateral water movement. So if you imagine looking down a stream channel, laterally, I'm talking about onto floodplains, or even vertically and laterally into the subsurface I talked about where groundwater is stored. This does multiple things, right? So on floodplains, water being moved on them helps water and just keep that riparian vegetation robust. In a groundwater sense, we're essentially refilling a sponge. And that effect is significant, maybe more so than a lot of us realize. So I recently read a paper where they quantified the volume of water stored beneath the ground surface versus in the visible beaver pond. And when you look at a beaver pond and the amount of water there, you're looking at least in this specific study, 25 to 35% of that total volume. So a good 2/3 or more of that water is being stored out of sight. But it doesn't stay there forever, right? So the combination of those beaver ponds and that recharged groundwater results in a slow release of water later in the season. And here in the Greater Yellowstone ecosystem, that later part of the season, summer, early fall, tends to be hot and dry, and that cold water is really important. Now, there are also geomorphic, or you can just think of them as physical benefits that we derive from the presence of beavers. So in a nutshell, all the things beavers do, cutting trees, excavating burrows, digging out canals, building dams, this drives what we call geomorphic complexity. And I know that sounds jargony. All I'm really saying here is that the activities that beavers undertake slow, spread, and store things like wood and water and sediment on floodplains and in the main channel itself. And so systems with beaver tend to get complicated in a physical sense, which is a good thing. And I'll add too, because this is just kind of where my heart lies, these aren't even transient effects, right? So there are some interesting examples in the literature where the presence of beavers within a valley network over a long period of time, thousands of years, right? Many different beaver colonies. They accumulate a lot of sediment, and at a certain point, you actually can notice a signal coming from the presence or absence of beavers in things like long-term landscape evolution, right? So I'm not saying it's a main driver of large-scale erosion and deposition, but it's a noticeable signal. It has an impact. And, you can't really say that about most of our native species. They don't tend to have impacts on geologic timescales. So pretty cool. Now, both the things I just talked about, those hydrologic and geomorphic benefits, combine together and directly relate to some of the ecological benefits that beavers provide to riverscapes. And this is something I know is near and dear to a lot of our hearts, right? So turns out that geomorphic complexity I talked about, it's really a jargony way of saying habitat diversity. And the more habitat diversity you have, the greater number of species we can support. And that's what riverscapes do. They sort of have this outsized value in a broader landscape because they provide habitat that's either required or preferred for a pretty significant majority of our native species. So pick your poison, pollinators, mammals, reptiles, birds, just about everything at some point in their lives really depend on these riverscapes and on some of these benefits that beavers are specifically providing to that riverscape. If you caught our last webinar, and I recommend you do if you haven't, Jared Becker was talking about how our migratory mammal species utilize a really vast and challenging landscape in Greater Yellowstone. Now, robust riverscapes are really essential stopover points while animals are moving from point A to point B. After all, they got to stay fed, they got to stay safe. Riverscapes turn out to be a really good place to do both of those things. And given how productive and preferred those habitats are, some of our charismatic, larger predatory species end up there as well, for reasons that are obvious, because that's where their food tends to be. And the main takeaway I would like you to have with this slide is that, by altering their environment, beavers are helping themselves. I'm not going to say they're selfless here, but they're also helping a host of other plant and animal species that depend on what they're doing. So beavers being around is a good thing. Now, how long have they been around? In North America, 7 or 8 million years, which, depending on your perspective, is a long time or not. But to put that into context, there were probably beavers in this part of the continent 3, maybe 4 million years before volcanism even started at Yellowstone Park, right? Back when that hotspot was further west under what is now the Idaho Snake River Plain. And over these millions of years, what we've gotten are riverscapes that have co-evolved with beavers. They kind of rely on each other and are sort of assuming that the other one is there. And until recently, we could have described North American beaver numbers as hyperabundant, right? It's like if you've gone to a talk about bison numbers in the North American continent, we had hundreds of millions of beavers in North America, maybe 500 million beavers. It's pretty hard to overstate the ecological significance of these animals. And that also goes for their cultural significance, right? So beavers have shared this landscape with native peoples for millennia, and they hold a really special and respected role for just about all of them, including the peoples whose ancestral homelands lie within Greater Yellowstone's ecosystem. Now, by the late 1800s or so, beaver numbers had cratered, not just here, in much of the continent. First from a sort of pulse of targeted trapping, and then subsequently sort of kept down from various land use changes that occurred along with Euro-American settlement. Now, due to the high demand for beaver pelts, Yellowstone and the surrounding environs were really not spared of this. We actually have diary entries from the 1830s, I believe, talking about how entire river drainages in Yellowstone had already been trapped out. That's 1830s, right? So for a long time. Now, the designation of Yellowstone National Park occurred after most of that damage had been done. We actually still had trapping occurring within the confines of this park for about another decade, till 1883, which seems odd to us today, and rightfully so. But we can understand this policy a little better by reviewing some of the primary source material, which is obviously a good way to understand people's perspectives. So I'll just do that right here. Quoting an old Yellowstone Park superintendent named Philetus, which, shout out. Without trapping, soon the beavers would construct dams upon so many of the cold water streams as literally to flood the valleys, terraced slopes, and passes, and thus render the park uninhabitable for men, as well as the many animals now within its confines. Ooh, excuse me. You know, yikes, a little bit, right? That's not really how we look at beavers today, but it is certainly how beavers were looked at back then, and it kind of explains even even after it was less economically viable to trap beavers, why we kind of hammered them for a while after that. Now, eventually, when beavers had been locally extirpated or at least greatly reduced from much of this ecosystem, in their absence, people started to change riverscapes themselves, both directly and indirectly, right? We divert water, we drain wetlands, we cut down riparian forests. We do all sorts of things that either immediately or over time start to change the way that these rivers act and sort of take shape on the landscape. We also toyed with the food web, right? So we can also think about certain species that we removed, predatory species, which then changed herbivory dynamics in riparian areas, which, you know, had and in some cases has still had an implication for the presence and habitat suitability for beavers. Now, these are, you know, immediate effects that manifest pretty quickly. What I'd like to point out here is that maybe a more nefarious thing that can happen is when you remove something like beaver, a key integral process to a complicated system, and then you start to change that system in their absence, you can also set these riverscapes on a sort of trajectory of change, I guess I'd say. So a long-term trend that is not immediately clear to those who are experiencing it in person. If left unchecked, too, some of these trajectories, I guess, can lead to an entirely different state of being for these systems, which turns out not to be a good thing. And I will say, and I don't want to be all doomy and gloomy, right? There's some good news here. Beavers have recovered somewhat since we really dropped their numbers. And now we have about 10% maybe of what we used to have across this continent. So that would be 15 to 40 million beavers from a source I looked up. You know, the bad news is that's still a lot fewer than we used to have, which means in many places, beavers remain absent or at low densities, which means some of these riverscapes continue to sort of shift to a new state of being. And there's two takeaways I want you to take from this. The first being that beaver-dominated valley bottom habitat types, kind of like what I've pictured here, used to be a lot more prevalent even in Greater Yellowstone than they are today. And second, we can think about this reduction in beaver distribution sort of equating to a reduction in many of those ecosystem benefits that we just discussed. In some cases, maybe an outright removal of those benefits, but at the very least, a reduced presence of those benefits. Now, if some of these systems become degraded enough, it can actually get to a point where beavers returning naturally on their own aren't going to want to use that habitat. Now, you know, I just said the words trajectory of change, so I need to define that immediately. And I think I'll do that by talking about, you know, what do I mean by riverscapes changing when beavers go away? Well, you can think of it as you're sort of removing these speed bumps posed by beaver dams that are in the riverscape system. And over time, that means flow doesn't spread out on the floodplain anymore, and it doesn't move slowly through the system anymore. It moves quickly, and it can start moving specifically within just the main river channel itself. That concentrated flow becomes more powerful, which allows it to erode, often size eroding downward, which is something we call incision. And that disconnects these rivers from their floodplains, right? And which is exactly what it sounds like. It means it gets harder and harder and harder to naturally flood up onto those floodplains because your creek keeps digging deeper and deeper. Over time, and if left unchecked, this will starve that floodplain system of the wood and sediment and water we talked about that is so important for driving habitat complexity. And so a simple way to answer the question posed at the top of this slide is that when beavers go away, a formerly complex and diverse system becomes a more simplified one. So here's one example of what incision looks like. Again, that's that vertical downward erosion I was talking about. So this creek has incised. This bluff you see on the left, hopefully you can see my mouse, historically would have been a wet floodplain, right? So it would have had sedges and shrubs and grasses and things that were dependent on a lot of water being present, as opposed to the sort of dryland adapted shrubs and grasses you see here right now. Excuse me. This is sadly a more common sight in the West than any of us would like to have be reality. And I should also say too, incision is not always linked to the removal of beavers, right? There are other key processes within riverscapes that if we alter them or remove them can also lead to a stream incising. But this is precisely the kind of thing that keeping beavers in a system can help us to avoid, right? So beavers do a really great job at what we call raising grade, which is keeping the elevation of the water high. And so, in a nutshell, the thing that incision does over time is dry out riverscapes, right? So where you might have had a wide valley bottom that was wet and productive, you might over time only have a very narrow strip that meets that qualification. And I'll sort of illustrate that over these next couple of slides. Okay, so we have a sort of series of slides in a row here, and we're going to start way back in 1964. So come with me, step back with me to 1964, a year I did not personally experience. But I'll set the stage a little bit. Okay, so it's 60 years ago, 1964. Robert Moog, a name we all know, just invented the first commercial synthesizer, remember? And Roberto Clemente had an incredible season for the Pittsburgh Pirates. He hit .339. He had 211 hits, both of which were leading the league. So another thing that happened in 1964, and something that's more germane for this presentation, is that some people started taking photos from an airplane over this remote wet meadow system. And they continued to take photos over this system, for the next 50 or 60 years. Now, in this first photo in the series, the system has already changed somewhat. I wouldn't call this a pristine riverscape, but I will say that the stream had not really begun to incise at this point. And one sort of clue that helps us visualize this, as you can see in wide swaths of the valley bottom here, this dark coloration, this is essentially soggy ground, right? So when this first photo was taken, we haven't had much incision yet. Fast forward to 1996, which is a year I did not look up strange facts about. And our stream has continued to cut deeper downward into that floodplain surface, which has been draining groundwater out of that sponge I talked about. And that formerly wet floodplain has really started to dry out. So you can see these kind of bleach white lines. This is essentially a dry river channel. And I want you to keep your eyes right here on these couple pine trees growing into the floodplain as I move to this next picture. Because by 2013, the stream has only continued to incise, right? Like I said, this is a trajectory of change. You can think of it as a trend. It is a thing you start and you kind of slide downhill. By 2013, this stream had incised between 3 and 6 feet, depending where you were. And that formerly productive and wet floodplain was entirely gone. And where I asked you to look on the picture here, you start seeing some of these dryland conifers actually moving into this former riparian area. And this is a common thing we see in riverscapes that have experienced incision, right? Species that can't survive in a riparian area suddenly can. And that's not because they've changed, it's because it's not really a riparian area anymore. So here's a photo of what that system looks like on the ground. This is from 2015. So this stream channel used to hold water all year. And when I took this photo, it was, late May. So it had probably had water in it for about a month in the early spring. And I want you to think about this, right? Consider the implications of this both at a localized and maybe a larger spatial scale. So, wetlands drying up, species that need those wetlands moving on or just disappearing. sort of interrupting a system that had been in a kind of dynamic equilibrium and sort of pushing it into a totally new state of being that is far less desirable from an ecosystem perspective. And now think about this happening concurrently, maybe at different rates and with different start points, but across a watershed or even across an entire ecosystem. And you start to really kind of visualize what the long-term removal and continued absence of beaver can mean for our riverscapes, and it's not great. Imagine too that you're a beaver, that you're walking up into this dry gully, and you've got your stick and bindle, and you're going to colonize a new spot. You're not going to do that here. There's no water here. There's no food here. So again, once these systems change enough, you kind of lose the ability for them to come back on their own. So sometimes doing nothing and waiting for something to fix itself, it might not actually happen, at least not on timescales that we're willing to live with. And this is challenging too. Let's think about the human perspective here, because that's really important. Because these changes take decades to manifest, or even centuries, it's really hard for individual humans to track them while they're happening. So, if I had been living here and my parents had been living here, you could probably ask both of us, hey, did this creek used to look different? And I'd be like, not really, right? It's always kind of looked like this as far as I can remember it. And that's not really true, right? But it's a natural human response because we sort of apply a lot of weight to what we have seen and experienced in our lifetimes. And, we live for a little while anyway, but we don't live long enough to fully witness some of the transformations that these riverscapes have experienced. And this here, I just sort of wanted to highlight again, like this is where that historical floodplain surface would have been. So think of green, think of wet, think of vegetation, think of, a better looking system than this, right? And this is just a small part of the story, right? So we've talked about what happens when we lose the beneficial presence of beaver, but now I want to kind of transition into talking about how restoring beavers is really essential, not just to bring back some of the benefits we might have lost, but looking ahead from a climate change standpoint. Now, the scientific literature is clear on this. When riverscapes lose key processes that sort of govern their form and function, they become a lot less resilient to external threats, right? And that includes external threats that are a result of climate change. By resilient, all I mean is the ability of an ecosystem to either resist or adapt to those external changes while still maintaining its functionality, providing whatever those ecosystem services are that we or other species rely on. And so a climate resilient system can weather the external stressors that we know are coming down the pike. So changes in precipitation, increased temperature, or more frequent fires. And there are a million stressors like this, but maybe we'll just focus on one. And I picked this one because it's not a modeled change. This is an observed change. I should say too, in full transparency, I stole this slide from a previous GYC webinar where we talked about the results of the Greater Yellowstone Climate Assessment. 10 out of 10, awesome webinar and an awesome report if anyone on this call today wants to follow up and learn about how this ecosystem has been and will continue to be changing. But focusing on this figure here, this figure showcases changes in monthly precipitation observed across the Greater Yellowstone ecosystem since 1950. So in a nutshell, our spring and fall periods have gotten more wet than they were historically. Our winter and summer periods have gotten more dry. And this really matters in a place like Greater Yellowstone. As I've already intimated, we have pretty hot and dry summer and fall periods. More drought or extended drought periods is a great example of an external climate-driven stressor to riverscapes. That can be a real detriment to the system. But here's something cool. By storing spring runoff and recharging those shallow groundwater aquifers, beavers create drought-resistant conditions in the riverscapes that they occupy. So they hold soil moisture and release water in late summer when it's really sorely needed by plants, wildlife, or even people. And as things warm up and more of our winter precipitation comes in the form of rain instead of snow, it's going to become progressively more important that we are storing water in surface ponds like a beaver pond, as well as groundwater, because we won't be able to rely as much on that snowpack storage that we've historically been able to. And we can therefore say, and this is backed up in the literature, that riverscapes with healthy beaver numbers tend to be more drought resilient than riverscapes without them. That's awesome. And what's even more awesome, I think, is how we consider the effects of beaver from a wildfire and climate perspective. So fire, as we know, is a natural event on the landscape, but we are fully expecting more fires, so higher frequency and larger and hotter fires, more intense fires, I should say, in the coming decades due to climate change. And this effect is going to be magnified in places within our ecosystem where we've been suppressing those fires historically. Now, the concern we have, as many do, is how will our native plants and animals be able to recover between increasingly frequent or increasingly intense burn events? There are some really cool real-world examples of what we might expect as it relates to beaver, right? So these photos are from a fire in Idaho in 2018. I bet many of our viewers are familiar with this. This is the Sharps Fire. And what's significant is this fire burned through a riverscape that had both relatively intact sections and more sort of degraded sections, right? So on the right, you have an example of what a system looks like when it's in size downward. It's more disconnected, so it's dried out its historical floodplain, and you maybe don't have beavers storing that water on site, versus on the left, when you do have those things, and you do have a higher groundwater table. The impacts are pretty significant. And I'll be the first to say, right, I have a science background. Pictures don't equal science, but science equals science. And I've just pulled one example here, but there are a lot of great examples in the literature pointing out how this effect really is something that can be expected and observed in a more analytical sense. So we don't need to dig into this slide. Suffice it to say that the y-axis, so the greater scaled NDVI difference you're seeing, correlates to more vegetation change due to a fire. And by change, I mean burn. So a higher value on this y-axis is bad. And that is what you have on the left when you don't have beavers. On the right, you have a lot less vegetation change, i.e. less damage to riparian vegetation when you have beavers in a system. And this is an aggregate too. So this actually represents a whole host of creek sites in 5 different states, including 2 states within the Greater Yellowstone ecosystem, Idaho and Wyoming. And there's a bunch of other cool examples in the literature that I don't have time to talk about, but that relate to beavers and post-fire sediment storage, or beavers and attenuating post-fire flood pulses, or bolstering carbon storage, or jump-starting post-fire nutrient cycling, or et cetera, et cetera, et cetera. And the sort of the takeaway I want you to have there is that beavers are really great, right? And while I established at the beginning of this talk that, you know, we love and value what beavers do because of the benefits they bring to ecosystems, it's really cool too to look at beavers through a climate lens and think about how they can emerge as one of our best partners in bolstering this ecosystem, preparing it for the impacts that we know are going to be coming due to climate change. And so another way to think of beavers that I like from a climate perspective is it's not just that we're returning a key part of an ecosystem, right? A missing component. We are specifically returning a specific part that is best able to help us withstand climate change effects. So I really hope I've made that point effectively to you all. So for these last 8 or 10 slides, I want to pivot a little bit and talk about some of our actual work as it relates to supporting beavers, right? What does GYC's role in this field look like? And I'll sort of harp on a few examples. I'll talk about beaver conservation, beaver mimicry, planning for beaver restoration, and reducing beaver conflict. Let's linger. I really love this picture. Okay, so we'll start with beaver conservation, kind of the basic sense. And really, I think it's, I don't know, kind of straightforward, but also more interesting and complicated than you might realize, right? So we have to look across the Greater Yellowstone ecosystem and ask ourselves questions like, where do we still have beavers? Where did we historically have them but currently lack them? And why are we lacking them in those places where they're not present anymore? It turns out that even knowing where beavers are is not as straightforward as you might expect. Though I will say a lot of our friends and partners in academia or in other nonprofits or with state fish and wildlife agencies are really leaning into more accurate and comprehensive surveys of where beavers are and aren't. But there's a lot of work that remains to be done in that sense. It also falls upon us in the conservation community to advocate for the persistence and recolonization of beavers, right? So beavers can't show up at a congressional meeting and advocate for themselves. So groups like GYC need to do it for them. And that looks like a bunch of things. We can protect existing colonies and work to facilitate natural dispersal onto the broader riverscape. We can think of ways to incorporate relocating beavers into restoration projects. We can also work to avoid, I guess you would call them legal and statutory barriers that make it harder for both us and our partners to support beavers within the ecosystem, right? So there's definitely sort of a political side to this as well. How do we change beavers or how do we change rules when we want to move beavers from one place to another where it's not legal? Or how do we streamline the permitting process to make it easier to scale up how many projects we can support? And maybe most importantly, how do we educate and build support with landowners and land managers to where we are incorporating their concerns and their needs while still being able to advance, our sort of pro-beaver perspective. And I will say, just to throw a couple examples out there, we have some really wonderful and dedicated things happening in the ecosystem right now. So first, I want to give kudos to the Montana Fish, Wildlife, and Parks, who recently published a really fantastic manual. It's in its first version. It could be updated, but it's worth reading now. And it relates to how to either live with beavers or incorporate them into riparian restoration work. It is a phenomenal read. And there are also a lot of really passionate and effective individuals and collaboratives who are tackling some of these issues head on. As another example, I will reference the Montana Beaver Working Group, which is just a really kick-butt awesome organization who are really tackling these issues head on with the involvement and support of GYC, as well as many other local and regional organizations. The key to me when it comes to this beaver conservation work is bringing together a range of agency and nonprofit and scientific and private partners with a kind of wide range of skill sets and sort of different kinds of resources and working with them to achieve something on the landscape that is greater than any of us could do individually. One example of this is called beaver mimicry, which I'm sure many of you have heard about. So we often have situations where we lack the habitat to effectively restore beavers or allow them to recolonize on their own, or perhaps we just don't really have the social support to have beavers so close to something like human infrastructure. In this scenario, we can imitate beavers by building dams and other woody structures ourselves. That's what beaver mimicry is. Now, I will say this is more often done with the intent of reintroducing beavers or allowing them to take over the project later on. And that's because they will maintain and build upon these dams themselves. Whereas if they're not present and if we are working in the absence of beaver, that falls on us. And it kind of goes without saying, right? But beavers are the better call. They live on site. You don't have to pay them. They don't take days off. They even put their kids to work. And I don't think any of those things apply to most working human individuals. So, from that perspective, I think beavers are kind of the way to go when it comes to, bringing back these benefits to riverscapes. Now, GYC, for their part, we support these kinds of projects kind of anywhere that we need to. So we have financed them, we aid in planning and permitting them, right? So kind of pushing through piles of paperwork, and we help build them. Really, our sort of philosophy here is we want to get involved to make these projects happen where they need to happen, wherever that is, and in whatever capacity that is, period, right? I mean, we just want to see this kind of work happening, because there's a big need for it. Now, when it comes to planning, right, being strategic about where and how we site these projects, this is something I find really interesting. It doesn't matter if we're talking about beaver reestablishment, if we're relocating them ourselves, or if we're just planning to mimic their impacts and not expect them to return. In any of these cases, we need to figure out maybe like what makes the most sense to work on first. And this is a science in and of itself. But I'll say analysis paralysis is real, folks. All right, especially in an ecosystem like ours where we've got 22 million acres and a whole host of different tribal and public and private landowners with different management plans they operate under and different goals and internal processes. It makes it complicated. It makes it hard to get everyone on board. But it's really crucial, we think, to make sure we are maintaining a seat at that table and supporting these agencies to help them be as proactive as possible when it comes to restoring beavers and trying to promote more climate resilient riverscapes. This is actually something I'm involved with right now. So just as a one-off example of a project we're working on, we're about a year into a project with various agency partners, looking at streamlining the implementation of these beaver mimicry or beaver relocation projects, with a specific focus on climate resilience, right? So how do you look at a large, complicated landscape and prioritize restoration projects by saying, okay, which smaller sub-watersheds are going to be at a higher risk of drought or fire or some of these other climate-driven impacts? And to do that, we have been compiling and analyzing a whole host of data sets that capture variables to help us make that sort of prioritization decision. And then we combine that information with where we know beavers are, or with mapping of human infrastructure or beaver suitability modeling, with the goal of creating sort of a tool to help direct our partners towards good locations to jumpstart these efforts. And knowing too that we're not always going to be ahead of that curve, right? Like some of these places will burn, some of these places will experience drought and other things. We're also looking at creatively thinking of a way to develop a protocol to get more of these projects out in a quicker time frame. So let's say you have a big wildfire and you're going to have sediment and water pulsing down the following spring. How do we get those projects in that fall? And lastly, I want to talk briefly about something else, which is trying to reduce conflict between people and beaver. So many of you are familiar with GYC's awesome work to reduce conflicts between humans and wolves, or humans and grizzly bears, or bison or elk. But there's also a real need for reducing human conflict with beaver. And, it's not apples to apples, right? Beaver aren't killing livestock and they're not attacking people, but gosh, they love to mess with human infrastructure. And, historically, beavers doing that kind of, were taken out of the equation. But for folks like us who want to, advocate for them and promote their distribution on the ecosystem, better strategy is to prevent conflict in the first place, or facilitate moving problem beavers to new locations. Now, this is gaining steam in our region, specifically in Montana, and it can look like a bunch of things, right? That could be altering regulatory frameworks that make it hard to move beaver, or doing proactive education and outreach, or even helping fund actual jobs, people's positions to educate and move problem beavers. But it's a really cool avenue for work and something we're excited to support. And I want to step back now for just a second. GYC has always advocated for our entire history for the protection of the lands, waters, and wildlife of this ecosystem. Protecting riverscapes in partnership with beavers is a key tenet of our climate-focused vision. And so any policy or program or management strategy that helps us get there is something we want to support. But working with beavers is really just one small piece of a much larger climate program, right? So I could have spent today talking about, the way in which we work to incorporate creative climate-focused strategies in land management planning. Or we could have talked about how GeoIC works to advance in the collection and usage of the latest climate science. Could even talk about something near and dear to my heart, which is how we are identifying and then protecting climate refugia, so places that will remain viable in a warmer world for certain sensitive fish and cold water aquatic species. So in a nutshell, our climate program is this wide-reaching effort that is constantly evolving. We sort of view the challenges presented by climate change as just that, challenges that can and have to be overcome in order to protect this really special place. And so our vision ultimately is of a future where the Greater Yellowstone ecosystem can be an example for how diverse stakeholder groups can come together and both prepare for the impacts of climate change and specifically work together to bolster and enhance resilience to climate change. Our vision is one for a productive and sustainable ecosystem into the future. And as we continue to work toward that goal, we really appreciate your continued engagement and support. We literally can't do it without you. And so with that, I just want to say thank you. Truly, I appreciate everyone for making the time to be here today and showing an interest in our Beaver work and more broadly in our climate program. So thank you. And Emmy, I will go ahead and pass it back to you to start the Q&A.
Yes, thank you, Kurt. So we've got some questions in the chat already. Again, I want folks to know that those are just coming directly to the host. So if you're not seeing your question pop up, don't worry, it's still coming to me. I'm collecting those. And if we don't get to your question today, we will follow up with you via email and make sure that your question gets answered. Kurt, we've got one question. What would be the minimum CFs for beaver survival? And if you could also just tell folks what CFs are. Oh, you're on mute. Sorry.
Sorry, did you say minimum CF?
CFs.
Huh?
Sorry,
oh, wait, here. I'll just look in the chat.
Yeah. Letter C, letter F. We can also.
Oh, thank you. Yeah.
Thanks, Kurt.
I'm sorry. So I assume you're talking about a discharge in streams, right? Are we talking about CFS or something else?
It's just CFS in the chat.
Oh, sorry, CFS. I thought you just said CF. Sorry. So
yeah, thanks, Kurt.
Sorry about that. Beaver, so they don't need a ton of water, right? When I lived in Colorado, I saw beavers damming a creek that I don't even know if you could register the flow on a gauge, if that makes sense, right? So they can make do with almost nothing. Obviously, there is an upper limit to what they can handle from a stream power perspective. You'll start to have their dams blow out enough that it's not worth their time. But I would say, I mean, gosh, I don't want to throw a number out, but the more the merrier. I would rather have too much water than too little. So, if we're thinking about this from the perspective of trying to balance between human use of water and how much water we leave in a system, I would say, well, how efficient can we be and what can we leave for wildlife to use? I think that's how I'd answer that question.
Great, thank you. Another question we've got is, does the Park Service allow beaver mimicry projects?
They do. Park Service does, BLM does, National Forest does, which are great, right? Really, the thing preventing more of these projects from being implemented on the landscape, it tends to come back to things like staff capacity. Funding has been a problem, but I would argue that, in the past 4 years, there has been actually a lot of funding going into this work, and that will continue to be the case. So, some of the bottlenecks we're seeing is less that you're not allowed to do the work. It's more that it takes time to tee it up. It's hard to get it permitted quickly. And like comparing the rate of these projects going out on the landscape versus sort of the scale of need and knowing that we're kind of up against some kind of a timeline, right? To like try to make these riverscapes more resilient. Yeah, if we can make that process easier, it will be a good thing.
Perfect, thank you. We've got another question. Any ideas about managing beavers in agriculture? I'm from Idaho and water diversion is king.
Well, it is, right? And I don't anticipate that changing anytime soon. So, when I talked about beaver conflict work, you know, from my understanding of some of the positions that have been funded through the National Wildlife Federation and others up in Montana, is that they're seeing a lot of success in working with landowners. I mean, it's like literally having a hotline where you can call and it's not Batman showing up, but it's someone who knows a lot about beavers, and they can literally provide materials and expertise and help you deal with specific problems. So, they love to dam culverts. They love to dam diversions. There are physical structures that can be built and they're relatively cheap, that can discourage them from doing so. And, hey, don't get me wrong, that might not be enough. Or maybe a landowner doesn't want to deal with maintaining those through time, which is understandable, right? Even if they're paid for upfront. Typically the people paying for these things aren't able to come and maintain them forever, right? So in that case, that's where relocation comes in. And from my experience, a lot of the issues on irrigated ag lands, I grew up at the mouth of the Snake River, so I get what you're saying. It's it's often easier to move those beavers, which again is a great solution, especially if you already know places further upstream, maybe on publicly owned land where it's like, gosh darn, we'd love to have beavers back, but they're not coming in on their own. Well, great, we can go down to Burley or wherever and haul them out of there. So yeah.
Great, thank you, Kurt. We've got another question. Do beavers improve water quality through the creation of wetlands? And how does the removal of wetlands from the protection under the Clean Water Act impact beaver populations?
That's a good question. So, in a nutshell, generally, yes, although I will put an asterisk there, which is that it kind of depends on what metric you're looking at. I know there have been a few published studies that look at things like temperature, right, which is an element of water quality, or like, certain nutrients, and they weren't able to say if beavers were helping or not. There are many examples of water being tested in sort of a control site and a place with a bunch of beavers where there is definitely a positive impact. And so I would answer that question by saying it can be awesome, and other times it's hard to measure the difference. It has not been, to my knowledge, recorded as being a detriment to water quality ever. And I will add as well that from the sort of regulatory change we saw with wetlands, it's probably not great for beavers. And I say this because when you're not obligated to protect something or manage it a certain way, i.e. leaving that water where it is, well, then you can drain it, get rid of it. And, that's, to go back to that first question, how much water in CFS does a beaver need? More than zero, for sure. So, yeah.
Great. Let's get at least one more question in there. Kurt, how well do beavers survive a large wildfire if their habitat is relatively intact?
Pretty well, at least to my understanding. Now, I do have a geology background. I don't want to pretend like I'm also a biologist, because that would be a lie, but I will say it seems like they do well, right? I mean, just about everything they eat and build with is in that floodplain area. So if you have high groundwater elevations and it's not getting scorched, they're probably fine. And I don't know, I'm sure there could be, I'm trying to think of a situation in which they could still suffer. I suppose you might see an increase in predation. This is speculative, but I mean, if most of a landscape is burned and a lot of prey species are even more than usual are congregating on a river, yeah, maybe you would have more beavers getting eaten up. I mean, there are a lot of things that like to eat beaver when they can get a hold of them. It's not unreasonable. I will add as well, and I'm sure Emmy was probably going to say this right after I answer this question, but I will happily share my email and I will happily reach out and answer questions, because I realize, there just is never enough time to really dig into these things. So anyone who wants to go back and forth and chat about this, I'm happy to do that at any time.
Yes, thanks for that, Kurt. And also, again, I've been collecting all of the questions. If your question was not read out and answered, we will be following up with you to make sure that you get your question answered. And so we're just right at 5 o'clock. So I want to say thank you to Kurt for sharing his knowledge and enthusiasm on beavers, and then also what GYC is working on to enhance climate resiliency in Greater Yellowstone. I want to thank all of you for joining us today. You guys really make our work possible, and we appreciate how much you care about this remarkable ecosystem. Wanted to say we have one more webinar coming up next week about Greater Yellowstone wolves with GYC's Wildlife Conservation Coordinator, Brooke Schifrin. She's done a few webinars with us before. If you've had a chance to hear her talk about wildlife, it's a real treat. So I highly recommend joining us. You can sign up on our events page. I'll also include a link to it in the email you'll receive tomorrow, which will also include a link to the recording. So you can watch it again if you like, or share with a friend or family member. And then also, if you'd like to support our work, we'll have a link to donate in that email as well. So again, I wanted to say thank you to everyone for joining. Thank you to Kurt for presenting, and we'll see you next time, everyone.